Hello there. In this video we're going to go over incenter and why the angle bisectors of a triangle are concurrent, meaning they all intersect at the same point. So for the time being, let's just concentrate on two of these angle bisectors. So these are both angle bisectors. They intersect somewhere, and where they intersect actually has some interesting properties. So I'm going to label these points. Now, this can be a little bit misleading since I already have the circle drawn in here, but I'm going to be interested in the shortest distance from that intersection point, I, which will become the incenter, to the line AB, and we'll call that point X, and the shortest point from I to Z, and Z is on the line AC. So in other words, I'm interested in this red line and this red line, and because it's the shortest distance, that has to be a 90-degree angle at both of them. So I have an angle back here that was cut in half. I have this blue line here, AI, that is shared, so that's by the reflexive. And I have this 90-degree angle because those points, Z and X, are selected to be the closest points on their respective lines to I. So I wind up having a triangle here and a triangle here, and those triangles are congruent by the hypotenuse leg congruency theorem. And that gets me that each of those red lines is the same length. Okay, so now I'm going to back up and show that I get the same thing when I come in from the other side. So I got those angles, because BI is an angle bisector. They share the line BI. And then I'm using different colors now because I don't know that this length is the same as this one. So I'm looking at this orange length here and this orange length here. And they're selected to be the X and Y are selected to be the closest points to I on their respective sides. So I know that both of those angles have to be 90 degrees. And that gets me the two triangles. Again, by the hypotenuse leg congruency theorem. So then I got xi congruent to yi, and then I can compare that back to the original. So what this means is that this point I is equidistant from the sides of the triangle, and that means that you could fit a perfect circle in here right there that touches the edges exactly. Now, the only thing left to do is show that that point I, which was the intersection of the angle bisectors for A and B, is also on the angle bisector of C, and not that C's angle bisector goes off somewhere else and kind of whiffs entirely. So we're going to do that by looking at the triangles here and here. And we already know a couple important things about it, namely that the angles in question are both 90 degrees, and these lengths we had previously proven that they are congruent to each other. We did that back here. So I get those 90-degree angles, I get those shared sides, I got the reflexive one there, it's CI, so that gives me the two triangles. And that is true by hypotenuse leg. So now I realize that maybe you caught this much earlier in the video. I'm not going to change it, but my assertions back here actually were wrong. I was so excited to use the hypotenuse leg theorem, but it only works in this case, because only in this case up here did I know that side that was being shared, those two sides, and then the 90-degree angles in there. Previously over here, I knew this side was shared between those blue triangles. I knew these angles, and I knew these angles, but I didn't know any other sides. So hypotenuse leg, really I only had the hypotenuse. I had no leg. I was assuming a leg to prove a leg. So assuming the conclusion. So hypotenuse leg here is wrong. This should be angle side congruency theorem. And same thing over on the purple triangle. That was wrong. That should also be angle side. Wow, glad I caught that. Even monkeys fall from trees. I'm going to leave it in the video. Hopefully you caught it before I did. Okay, so we're going to finish this one up now by talking about the angles. We get those by corresponding parts of congruent triangles are congruent, and that means That I is indeed also on the angle bisector of angle C up at the top. So all of those angle bisectors do intersect at the same point, I. I'm very embarrassed about this angle side mistake up earlier on, but it is also a good sign of how you can go through and maybe realize something as you continue to work through the problem. Okay. Character and scholarship for life.